In this video, we're going to tokenize the text that we just cleaned in the previous video. So just a reminder here, we're talking about tokenization. When we look at tokenization, what we're doing is we are reducing to a smaller unit of text. And when you tokenize, you can choose to use stemming. So it's going to remove the endings of words to find a common root. You can do lemmatization that finds the base word. And when we can tokenize by word or we can tokenize by sentence. So let's look at how we do all of those. We are working here in the text mining Python workbook. Just a reminder, you can find that at drstephpowers.github.io/BIA. Under chapter 7 here, we are doing text mining. And in addition to our code here, you'll also need some of these PDFs that we in our last video cleaned. If you click on them and then you hit this download button here, you can download them, save them to your Google Drive. All right, so in order to do our tokenization, let's start with word tokenization. We'll do sentencing after. And we're going to need a number of packages. These are also going to be packages we'll use in the next couple of videos. So this svgling, this package, we're going to use this to model chunks of text in kind of a tree format. So when we start to do visualizations of our text, we're going to be using this one here. It is not already in Python, so we will need to install it. Then what we're going to use for the majority of our tokenization here is the package called NLTK, so the Natural Language Toolkit. And from that we're going to import word tokenize. We're going to import the stop words. Recall that stop words from our previous discussion are words that don't add value, like a or with or and we remove these when we're doing our bag of words using our count vectorizer, which is what we're going to do first. We also remove those stop words if we're using other embedding or vectorization methods as well. So remove the words that don't add value. In order to do that, we're going to need that list of stop words, and so that's what you're importing here. And then if you want the option to be able to stem or lemmatize, then those are the pieces here: snowball stemmer, wordnet lemmatizer. The POS tag, that is our part of speech tagging. And so depending on what type of analysis you are doing, you may want it to be able to identify the part of speech. And then we can do chunking. This chunking here allows us to put groups of words together. Okay. Then finally, this one that you see here, the string, this is going to help us modify strings of text. So let's import all those things. Then what we're going to need to download is a number of pieces here. We are going to download those stop words. Okay. And then these are basically pre-built algorithms to help in terms of doing our analysis. And with punct, this is for punctuation to find the beginning and ending of sentences if we are going to be tokenizing by sentence. WordNet helps to find synonyms or similar meanings of words and antonyms. And our averaged perceptron tagger, that contains pre-trained data on parts of speech. And then the MaxNTNE chunker, that's common combinations of words, noun groups, verb groups, and so on. And then words contains common words and text that tend to be near each other. So these different packages here are some of these pre-trained algorithms and lists to help do our analysis. So we need to download those. Okay. Now we're going to create our pre-processing pipeline. So again, as we're talking about pipelines, we're here in the data pipeline doing our pre-processing. And so we have extracted the data from our PDFs in our previous video. And now we are transforming the data into tokens so that we can actually use it in our models. All right, so let's define this function as token creator, and we'll give it some set of clean text because in our previous video we had created these clean versions of text. All right, so we're going to call tokens. That's going to be our word tokenizer is going to be applied to our text and create our list of tokens. We are going to set the stop words as being English stop words. So if your information's in a different language, you need your stop words to be in that same language. And the idea here is we're going to filter our tokens. So token for token. So this is the loop, right? So this would be like for I in whatever the list. Our list here is tokens. So for token and tokens, if token.lower, not in stop words. So what it's doing is it's going to go through the list of tokens and it's going to keep them in that list of tokens as long as they are not a stop word. And we're going to call that filtered tokens. Then we have here our stemming. So we're using Snowball Stemmer. It is stemming using English words. We're going to lemmatize using WordNet Lemmatizer. And so what you see here in this next set are these loops. For token in filtered tokens, it's going to stem them. For token in filtered tokens, it's going to lemmatize them. So we are ending up with our list of tokens that have now been cleaned out from remove the stop words. And then we have a list of tokens that have been stemmed and a list of tokens that have been lemmatized. Okay. We're going to create a loop here, and this loop is going to take the lemmatized tokens and it's going to remove anything that is a digit, a number, and it's going to remove punctuation. Okay. Here, this is going to take our cleaned tokens that have been lemmatized. So we have our tokens, we have removed the stop words, we have lemmatized them, we've removed the numbers, we've removed the punctuation here, and now we're going to force everything to be lowercase. Okay. So that way, when we look at a word, if the word is at the start of the sentence or if the word is in the middle of the sentence, it still counts as being that word. So we want that to all be lowercase. That's what here is. We can do our parts of speech tagging. So we can take these lowercase tokens after it's all been cleaned up and identify the parts of speech. And then the other thing we can do is use that chunking on those parts of speech taggings to find named entities. So here we're looking for proper nouns based on the part of speech that it is. We want it to return the named entities, the parts of speech tags, the lowercase tokens. That's going to be the lemmatized one that has the digits removed, the punctuation removed, the lowercase removed. We also have the stem token separately if we want to use stemmed versions. Okay. All right. Let us run that function there. So you can, if you have other data sets, if you just kind of keep this line of code, these are all the steps in the process that you need. And so you could just keep this function, run this function in your new system, and then apply it. So we're going to do our token creator for the AI Canada, AI US, AI EU, and we can see we've labeled these. So AI can named entities, AI can parts of speech, AI can lowercase tokens, AI can stem tokens. Because it outputs all four of these things, what we want to do is make sure when it comes out of our function here that we have given it a name. So we're taking those same names, but right now we're going to add a piece in front of it where we call it Canada, US, or EU so that we can look at each one of these. So we'll just apply our function here to Canada, to the US, and to the EU. We could make this cleaner, more concise code rather than have it be each one of these separately, but for now we'll do this just so we can see the pieces here. So if we were to run, for example, stem tokens, You can see here, like the word include has no AE on the end, because as we had just talked about, when we look at stemming, go back and find it, we're removing the endings of words to find common roots. So just like improve had no E on it, we can see the same thing here with include. Okay. The challenge, of course, becomes what is really? What is that word supposed to be? You know, influence, we can tell, okay, influence, influencing, influenced. But some of these, it's really hard to discern what they are. So that's why, you know, we're not using STEM tokens as much anymore. To see what lowercase tokens look like, remember these are the lemmatized, which means we have a full word here. We're looking for the common word. And so you can see words like guide and use and generative AI. Notice that for these, they are all now lowercase. Okay. The numbers have been removed. So as we look through this list, notice there's no digits. Oh, maybe there are digits. What did we tell it to do here? Okay, token for token in lemmatized tokens. If not, token is digit and not token in string punctuation. So my guess here, these are kept in the system in that automated process just in case there's a relevance to date and time as exceptions as opposed to just a random 2 or a 4 in the system. Okay, so there's probably some exceptions to information. The parts of speech, when we look at this one, you can see that it has labeled the different parts of speech. And so what we have here, these different symbols or different labels are the different parts, whether we have a noun or a verb, and refer back to your training in English and when you did grammar as to the different labels for the parts of speech. So you can see how we're pulling our different information here. We can also tokenize based on sentences rather than words. To tokenize based on sentences, we're going to use nltk.tokenize import sent_tokenize. We'll need to create a pipeline for tokenizing the sentences. And so here we're going to define token_sent_creator. So create a tokenizer. It will take our clean text and it will tokenize the sentences. So sent_tokenizer is a command. And then what it's going to do is it's going to make it lowercase. That's what this next line here is it's going to make the words all lowercase. And it's going to replace any periods with empty spots. So it's going to take it sentence by sentence. So we do it after we tokenize. We remove the punctuation here. So that we have each sentence separate, and it's using the punctuation to separate out those sentences. So we will create this function that'll be our pipeline, and then we can apply that to our different data sets. So let's run this function here, and then we'll apply it to Canada and to the US and to the EU. And so if we run, for example, the Canadian one, what we see here is that you can see one sentence here is use watermarks to help users identify generated content. As a result, clients may be misled into believing they are interacting with a human. So these are phrases that we're getting from the data set. Remember, this data set is about generative AI used in Canada. And so guidance for how to use like ChatGPT if you work in the public sector. Best practices for all users of generative AI in federal institutions. Clearly communicate when and how the government is using AI in interactions with the public. So you can see it's taking each kind of sentence, it's separating out each component into a big list. So quotes around each sentence token, comma then to separate it from the next one. and we can go through that. So we're going to use our word tokenization to do things like word counts and create word clouds, some of that simple exploratory analysis of what's in the text. We can use the sentence tokenizer in the future when we are doing greater analysis. Remember here, let's just go back to our different word embedding methods. And so if you're doing BERT, for example, we are looking at full sentences, and word to vec considers word order. So when we're doing those more advanced methods, we want to use our sentence vectors. And for at least for this introductory part, we're going to focus on word tokens.